Hello dear friends, Patrick Peace here. How are you doing today? Wanted to make a short video to explain something that we may take for granted, but we may not really think about. I recently had a chance to travel to Tokyo, Japan. You can see my souvenir hat here from Japan. And I noticed while I'm flying in the aircraft, we are flying in a arc on the map that's in front of us. It shows you a map while you're sitting in the airplane of the path that the plane is taking. And you can even look out the window and you can see landmarks of different types. For example, as we're traveling from New York to Tokyo, we're traveling in an arc that travels north of what you may expect. We're passing the southern tip of Hudson Bay and continuing on all the way passing above Alaska. So you're traveling almost directly above the city of Nome, Alaska, the city of Nome, Alaska, and you're traveling across the Bering Strait. Now, New York and Tokyo are almost on the same latitude, slightly before the 45th parallel. You can follow them. Tokyo is slightly further south, but they're basically, on a similar. So if you're looking at a projection map, a flat map that you normally look at, you would see a direct line from Tokyo straight across to, from New York straight across to Tokyo, as almost a straight line on that map. And you would think that's the most efficient way to fly there, a straight line across the lines of latitude, right? Because on a map, we're conditioned to think, well, that's the shortest distance from the 45th parallel. If you're sitting on the 45th parallel on one spot, it should be the shortest distance. If there's another spot on the 45th parallel, you're going in a straight line. It only makes sense. And that would be true if we were living on a flat Earth. If the Earth was flat, the way we look at a flat projection map, you would look at one point on the 45th parallel and another point on the 45th parallel, and the shortest distance between the two would be a straight line. That would make total sense. Of course it would. That's only reasonable. On a flat Earth, the shortest distance between 2 points on the same latitude would be a straight line. But what do we see in actuality when we get into an airplane and we get in at New York and the plane takes off and it starts to go in this large arc going over the northern parts of Canada, northern Saskatchewan, northern Alberta. You cross the Yukon, almost directly above Hudson Bay, the southernmost tip of Hudson Bay. You can look out the window. You can look out the window and see the Bering Strait, the vast wasteland. You can look out and see you're traveling over Alaska. You're going in this arc. So how does it make sense to travel from 2 points on the same latitude to take this arc north and then back down again? Well, it makes sense if we're living on a sphere. I mean, obviously this is so basic, but most people take it for granted that they don't see this perspective. So what I'm going to do is I'm just going to do a short little experiment with a piece of string on a globe so that you can see why this is true, why it's shorter to go up north and back down again, because we are living on a sphere. So I'm going to switch the camera around and then I'm going to show you a little experiment that I did. Be right back. It's my little simple experiment. I've taken a piece of string and I've taped it approximately the end of it at New York City. And if you follow the parallel, the 45th parallel, straight across, as I mentioned, Tokyo is slightly south of the parallel. And I've marked the string with black ink. So that's the string that follows a straight line on a projection map. Follows along. This is, you can see here, this is the 45th parallel, and the string is slightly below. New York is slightly below the 45th parallel, and it's following along, and then it drops slightly, but there you go. Now this is the second string that I put. The second string goes from Tokyo. Actually, it's slightly, I could have made that string slightly shorter, but it's going. Look where it's going. It's going over Alaska. It goes right over Nome, Alaska. It crosses the Bering Strait. That's the flight path that an airplane takes and goes straight down. It almost crosses Hudson Bay. crosses the southernmost portion of Hudson Bay, and then it ends at New York. So if you're starting at New York and you want to take the shortest distance to get to Tokyo, guess where you're going? You're going north over, and then you're reaching Tokyo down here, the white string. So let's take these two strings off. Which one is longer, do you think? Well, obviously the one that's following the latitude, the 45th parallel. That's going to be longer. Let's take these off. I taped them on here. Let's take them off and see which one is longer. As I mentioned, the black string was the one that was following the parallel. Look at the difference. I'm going to have to lay this flat here. Maybe I'll just lay this flat on the table so you can see. The black one is the one on the right, and you can see the difference in distance. It should be clear. It should be obvious. This is the one that follows the straight line of a projection map. I marked it black. And this is the one that follows the curved path, following, because the Earth is a sphere, is following a shorter distance by this much. That should be straightforward and clear because we are living on a sphere. I hope it makes sense to you. So there you have it. You can see, there's nothing magical about it. There's nothing mysterious about it. It's straightforward. And of course, flat earthers will still have a reason why this is not the case and so on and so forth. And that's totally fine. But I just wanted to show that to you in case you've ever wondered why the flight path of an aircraft does what it does. It's shorter to follow the curvature of the Earth to get to your destination. Straightforward and simple. Thank you so much for watching. God bless you. We'll talk to you again real soon. Bye for now.